Well, good evening, everybody. Welcome to our conjunction live stream on YouTube. This is coming to you from the McDonald Observatory Frank N. Bash Visitor Center this evening. My name is Kevin Mace. I've been working here at the Visitor Center for a couple of decades plus. I have a couple of roles here. I take care of our technical needs here at the Visitor Center, also do some public programs, and we're being joined tonight by a couple of co-hosts. You'll be seeing them, being introduced to them shortly, but we're really happy to have everybody tuned in tonight. I know I'm seeing in the chat a lot of you have clouds where you're located tonight. We do have some clouds this evening, but we're hoping to get at least a partial view in the worst case. In the best case, we hope that those clouds completely clear off and we're able to show you all of our planned views this evening. I did want to mention here at the Visitor Center, we are not currently open. We were open until about the third week in November. We had to close down again after COVID cases began to explode across the state and especially in our area out here. So we're not currently open, but we do have plans to reopen on January the 5th, 2021. And stay tuned to our website and our social media channels to keep you up to date on that. I did want to show everybody where I'm coming from tonight. Many of you have seen our streams before. You know that we are located not in Austin, although we are part of the University of Texas at Austin. We are not physically located in Austin. We're located about 450 miles west of the main campus at UT, out in the beautiful Davis Mountains of West Texas. You can see a nice shot there showing our two primary locations out here, the two peaks, Mount Fulks in the foreground with our 10-meter Hobby Eberly telescope, and in the background is Mount Locke with our 82-inch and 107-inch telescopes there. Down in that valley, off the slope to the right there, going down from Mount Locke, is where the Visitor Center is located. I also wanted to show you that this evening. We're located at the Frank N. Bash Visitor Center at McDonald Observatory. We have a very nice visitor center, areas for folks to congregate out back during our star parties in our amphitheater, also our telescope domes that house a number of different telescopes, a few of which we'll be using tonight. We're going to talk more about those specific telescopes here in just a little bit. Did want to mention this evening that our planned program length is about 1 hour or so. In the chat over there on the right side of your YouTube window, if you have questions, make sure that you submit your questions along the way, and we do have moderators to take your questions and answer some of them. We will also be answering some of your questions this evening during the live stream. All right, I think it is time to talk about roughly what we hope to cover tonight. In our program overview, we're doing our introduction for you right now. Immediately following this, we're going to have our co-hosts' introductions, and they're going to tell us a little bit about the equipment that they're using tonight. And then, hopefully, we're going to have some super cool live views of Jupiter and Saturn. All of you know it's the night of the conjunction, the closest appearance of Jupiter and Saturn in our sky for quite a number of years. We hope to have some live views of that to show you. We'll talk a little bit about details of both of those planets. They're both fascinating planets to look at separately. And in addition to seeing them together tonight very close in our Earth sky, we're also going to talk about, well, basically how conjunctions can happen. And that involves a discussion about planetary orbits and things like that. And as soon as we've wrapped up our Jupiter and Saturn views, we're going to proceed into, if we can again, some live views of the moon. You might have noticed if you're outside earlier today, or if you're watching this outside right now, the beautiful first quarter moon is out there. And we hope to take a look at that this evening as well, and round out our viewing tonight with the planet Mars, which is still prominent in our evening sky. But we have reached the point in our program now where we would really like to introduce you to our co-host tonight. And I'm going to go ahead and bring in Stephen Hummel here. He's going to tell us a little about himself, describe his role here, and about the equipment he's going to be using. Hey, Stephen, how's it going?
Good. Thank you, Kevin. Yeah, my name is Stephen Hummel. I'm going to be operating this telescope you see right behind me. And here's a shot of it in action at night. But although it doesn't look like it, I am in fact outdoors. There's a big hole above my head, and it's nice and cold out here. But yes, I'll be using this telescope behind me to show you some views of Jupiter and Saturn, as well as the Moon and Mars as well, if we get to that. But the telescope is a 16-inch diameter. It's the diameter of it. Telescope that's 0.4 meters. It's a Ritchie-Chrétien type telescope. It's the same kind of optical layout, essentially, as the Hubble Space Telescope, just scaled down and here on Earth. And attached to it, I have a camera located here. The camera is monochrome. It's a fancy way of saying it's black and white. And there's several reasons why we're going to be using a black and white camera tonight. The main reason is that it's really not dark yet at all, actually. The sun has just set. There's no lights in the dome. This is all illuminated from daylight. And in order to filter out that daylight on our views of the planets, I'm going to be using a red filter on a monochrome camera. And that will allow for a very high contrast view, which will greatly improve the viewing quality. That being said, we do have some clouds tonight, as you mentioned earlier, Kevin. Here is a live shot of the sky with an all-sky camera. And we can see there's the moon right there. So you can see that there are some thin, high clouds across the sky, kind of pervading the sky. The good news is that it should not stop us from seeing anything tonight. It may fuzz our view a little bit. If there's a slightly thicker patch, it may be problematic for a moment or two, but we still can see things through these thin clouds. I don't have any sophisticated technology that will completely eliminate the effects of clouds, but I do not believe that these are going to be enough to really stop us tonight. So that's our weather at the moment. It's nice and cool, 50 degrees and dropping fast, very low humidity. So aside from the clouds, very good viewing conditions. But back to you, Kevin.
All righty. Well, thank you very much for that, Stephen. It's good to see, by the way, on that weather cam there, that it is looking better than it was. We've been setting up over here for about the last hour or so, and I think that's probably the lowest level of clouds that I've seen during that time, although it could just be it's getting harder to see those clouds because it's getting dark. All right. Well, thanks, Stephen. He says he's getting better, and he has a lot more experience at being outside under the real sky lately. So, all right. Well, it's now time to bring in our other co-host this evening, Frank Cianciolo. I'm going to go ahead and add you in here, Frank. Can you tell us a little bit about you, your role here, and what you're using tonight to get that awesome view?
Yeah, so this is thanks, Kevin. This is a live view, and I'm seeing that I have something apparently not set up quite correctly. You're not supposed to be seeing all of the Windows bars and stuff like that. But anyway, we'll try to work on that. The equipment that I'm using is a ZWO color camera, 294 color camera. And we wanted to have the color camera to give you a sense of more of a kind of a what you would see with the naked eye. And I'm using that color camera not with a telescope, but with a lens. It's a Canon lens, zoom lens that is, I can't remember the bottom focal length is somewhere around 24 to 85 zoom lens, I believe. Anyway, but we're using it at its widest setting. So nice wide field. And as you can see, we do have clouds, hopefully thin enough that we'll be able to see Jupiter and Saturn through those clouds as it gets a little darker. The brightness that we're noticing is of course, the sunset is just slowly fading, so that's changing rapidly. Because I am not, as demonstrated by the fact that you can see those Windows bars above and below that image, I'm not much of a Windows user. I'm more of a Mac guy. I am going to show you something that I'm going to inelegantly slide into the view here. This was a shot a little earlier. Obviously, the sun was still up at this point. But the reason I snapped it was because you can see the sun. Oops. You can see the sun here. And you can make out kind of a dark arc here. That's kind of the inner edge of what to the naked eye was a little bit more obvious of an arc here. But it more importantly is this bright spot over here. this bright. So you can actually see a little color. Hopefully, you can see that on your screen at home. But that arc, or that color here, we got a little bit of red on the interior to blue on the outside. That is what's known as a sundog. And it's just one of the many different optical features, the optics that water vapor and sunlight will produce at various times. If you're observant enough, you may see these. They're actually not all that terribly uncommon. As long as you have thin clouds and sunlight, or even moonlight, you're going to see some of these sorts of optical phenomena, and you just have to look. But anyway, called a sundog, always 90 degrees around on that arc. If you start from directly overhead, it would be 90 degrees. And then sometimes there's two of them. In this case, there were no the proper sorts of clouds on the left side. Besides that, the tree was blocking it. But nonetheless, kind of a cool little optical feature that we saw a little bit earlier in the before we started the program. So yeah, so I'm going to bring more of a kind of a live or a naked eye view for us this evening, and hopefully not get visited by any wildlife while I'm doing it. Back to you, Kevin.
All right, that looks really cool, Frank.
All right.
I don't think you mentioned it, but what exactly is your role here at the Visitor Center?
Oh, no, I didn't mention it. My role is I'm the Visitor Center manager. I've been out here for, like you, decades, and well, actually, probably not for very much longer. Going to be retiring at the end of summer, is at least the plan at this point. So, but yeah, I've been out here. I manage the Visitor Center and its operations for many years here. All right.
Yeah, I was going to throw in, Frank is my boss, only for the next few months.
Right.
We'll see what happens after that.
I don't try to tell you what to do for the most part.
Yeah. All right. Well, thanks, Frank, for that. All right. Well, we are to the point in our program now, at least where we had planned to have some live views. We're going to start out tonight with Stephen's live view. Is that live? Can I see it shimmering around? Looks live.
That is the real deal right there. That is live from the telescope behind me. And on top, you can see Saturn and those famous rings. Bottom, that is Jupiter. Now, despite what it looks like, there are still actually some thin clouds here. If I adjust the exposure a bit, you can see that Jupiter has some very subtle bands across it. But if I really adjust the exposure a lot, you can see that there are dots next to Jupiter as well. We've got a little dot here, and one more dot there. And there should be a fourth one, but I'll come back to that in a minute. So yeah, this is a live view of Saturn and Jupiter. This is the conjunction. Now, one of the reasons we're starting this program kind of early, at 6 o'clock, it's really not even dark yet, is because of the position in the sky. So at the moment, I'm aiming the telescope relatively low. You can see the telescope aimed here. And here is a piece of software I use to operate the telescope. And that is a live view of the sky there on the left. But this is the wall of the dome I'm in. And Jupiter and Saturn are right above the wall. So if it goes below that, obviously I'd be aiming the telescope at the wall, and that wouldn't be very interesting to look at. So it's just above, just high enough. It'll be setting here local time around 8 or so, or a little later than that. But the lower it gets in the sky, the more atmosphere you're looking through, and so the more air you look through, the more that will make the image shimmer a bit. So if I adjust the image again and kind of bring it back a bit, you can see there the daytime glow of the sky. It's not standing perfectly still. It is kind of moving around a bit, and that's because of the air we're looking through. Just like when you look at a road on a hot day, you get that shimmer effect. That's happening all the time as well in the sky. That's the reason stars twinkle. So when you look up in the sky, or perhaps you do it tonight, you go out wherever you are, and you'll see Saturn and Jupiter right next to each other in the west, about a little after sunset. It's the best time. And you'll notice that they do not appear to shimmer like the stars. The reason planets don't appear to shimmer like stars is because planets are not points of light. As we can see features, we can see the rings of Saturn, we can see the disk of Jupiter, whereas stars are basically almost perfect points. And that means if there's any variation, any distortion in the light, as the light comes down through our atmosphere, it will become smeared, and that is what causes stars to twinkle. Whereas with a planet, because the light's coming from multiple kind of angles, the smearing effect gets averaged out, and to the eye, we don't see it twinkle nearly as much. Point of the story is, when you go outside tonight, if you think you see Jupiter and Saturn, they shouldn't be twinkling. All the other things in the sky, all the other stars will be twinkling, especially if they're down low, but the planets don't, because they are not true point sources. But again, this is the moment. This is Jupiter and Saturn in conjunction. Technically, the moment of maximum conjunction was earlier today in daylight here. Here's an image I took. Actually, an image a friend of ours, Lloyd Overcash, took yesterday. Last night, and you can see that yesterday they were a little bit further apart and their positions were slightly different. You can also see the moons there as well. Note there's 2 dots over here, a dot over here, and another dot over here. Those are the 4 Galilean moons of Jupiter. But we look back at the live view, and it's still not totally dark, so we're going to struggle to see the moons, but you can kind of see one there, and another there. So the positions of everything have changed since yesterday. Jupiter has moved. It was kind of over here. And over the course of the last about 24 hours, it's been drifting off this way. So technically, when it was over here a few hours ago, it may have been slightly closer to Saturn, but it's still very close right now. And how close is it in the sky? That's 8 arc minutes. How much is 8 arc minutes? Well, the moon is 30 arc minutes across, and the field of view of the camera across is roughly 20, or about a third of a degree. So that's very close. But yesterday they were 6 arc minutes, 6.1 arc minutes. So they were a little closer yesterday. So I'm going to talk a little bit about the planets themselves, because they are very interesting even on their own right. It's cool to see them this close, but Jupiter and Saturn are, of course, the prettiest objects, some of the prettiest objects in the sky to see in general, even when they're not posing for a picture like this. So here's Jupiter taken on a different night under better conditions when it was higher in the sky with more magnification. And here's Jupiter taken a few hours later on the same night. Just a few hours makes a big difference on Jupiter. And that's because Jupiter is spinning very quickly. A day at the equator of Jupiter is about 10 hours. And it's big. It's 11 Earths across. And it's 318 times the mass of the Earth, which makes it the largest planet in the solar system by far. It's actually more massive than all of the other planets in the solar system combined. But it's spinning so quickly that it actually is not perfectly round. You can actually see it's slightly wider around the equator compared to pole. It also means that over a course of a few hours, you can literally sit there and watch it spin and watch different features come around on the clouds of Jupiter. And Jupiter and Saturn as well are both gas giants. They are mostly made of hydrogen and helium. This data was taken from the Juno spacecraft, which is in a very close orbit around Jupiter and is able to take incredible high detailed images with the most detail we've ever obtained, far better than we can get from here on our perspective on Earth. And you can see those swirling cloud bands, mostly hydrogen and helium, as well as other things like ammonia, ice and gas, and the nice swirly patterns. Jupiter and Saturn as well, again, are gas giants, meaning they don't really have a surface. They're just giant balls of gas for the most part, although the deeper you go into those clouds, the denser it becomes until you be crushed. And at the core, there may be a rocky core, but there may be some strange forms of ices as well and other solids, or even perhaps metallic hydrogen, something very unusual. But yeah, the swirling cloud bands of Jupiter are really what make it famous and interesting to see. And they also change over time. The storms come and go. And picture there is the Great Red Spot, the most famous storm of all. And it's about 2.5 or 3 Earths across. And it does actually change in size. It has shrunk over the past few decades. Let's go back to the live view. So on the live view, we can see, again, those dots are starting to be a little more obvious as the sky continues to get darker. We've got a little dot here. Let's make this full screen and just kind of make it a little easier. There's a dot right there, a dot right there, and another one there. And I'm going to stretch this image as the most we can. There we go. Make it more obvious. Yeah, those are the moons of Jupiter. But there's only 3 visible. The fourth one that isn't visible is actually directly in front of Jupiter, and Jupiter itself is so bright, it's sort of washing it out and making it hard to see. But those are the 4 Galilean moons of Jupiter, so named because, of course, Galileo discovered them. And this one right here is Io. And Io, seen here by the Galileo spacecraft, named after, of course, Galileo the astronomer, is spelled like it sounds, I-O. And it's a small volcanic moon, the most volcanically active body in the solar system. Next to it was Europa. Europa is a moon that's just around Io and Europa are both around the same size as the Earth's moon, a little bigger. And Europa is an icy moon. It's got all those cracks because beneath the layers of ice, there's a vast ocean of water. And as it orbits around Jupiter, the gravitational pull of Jupiter is so immense, especially on the side closest to it, that it stretches and cracks the ice and causes friction and also causes the ice to crack. But it also heats it up just enough for liquid water to probably exist beneath that icy surface. The next one out, the outermost of the 4, is Callisto. It is not as photogenic. It doesn't get nearly as much attention as Io or Europa, but you can see it's a cratered surface, and it's also very icy, but very rocky as well. And next up is Ganymede. Ganymede, again, is currently directly in front of Jupiter as we see it from our line of sight, and thus we can't see it very well tonight, but it is the largest moon of all of the moons of all of the planets in the solar system. Ganymede is, in fact, larger than the planet Mercury, and it probably has more liquid water than there is on all of Earth's oceans. But like Europa, it's trapped underneath an icy, kind of dirty surface, but with a rocky core beneath that. So those are the 4 Galilean moons of Jupiter. Again, you can see 3 of them, one there, and one there. But let's turn our attention to Saturn. Saturn, of course, the famous ringed planet. Now, the moons of Jupiter are, of course, very close to Jupiter in reality. Well, there's still many thousands of or hundreds of thousands of miles from it, but still that's close in the grand scheme of things. But Jupiter is about 550 million miles away from the Earth at the moment. 550 million miles. It takes about 49 minutes for light to travel that distance. So in other words, it's 49 light minutes away. Saturn, by contrast, is much further. It's about 1 billion miles away from us at the moment. And it takes the light from Saturn about 90 minutes or an hour and a half to reach us. So in other words, we're seeing Jupiter as it was 49 minutes ago and Saturn as it was an hour and a half ago. Pretty big difference. But Saturn, of course, is, as Frank likes to joke, any planet with an ounce of self-respect ought to look like. It's got rings. And the rings of Saturn are mostly made of particles of ice. Here's a picture when it was higher up earlier in the year. And those rings are just wonderful. The rings are particles of ice, a little bit of dust as well. And most of those chunks of ice are no bigger than your fist. And there's just millions of these pieces in orbit in a plane around Saturn. They are about 170,000 miles in diameter across from edge to edge. It's pretty big, but in most places they're a few feet thick, maybe no more than a few hundred feet thick. So if you were to scale that to a sheet of paper, the rings of Saturn would be thinner than a standard sheet of paper if scaled down to that size. And around it, you can also see its moons. Let's look back at the live view. and we may catch a glimpse of Titan if it's dark enough. Let's see here. Oh yeah, maybe. Well, maybe not. It's not quite dark enough yet to see Titan. Maybe later on. But Titan is Saturn's largest moon, and Titan is really interesting for a lot of reasons. Titan is the only moon of all of the moons of all of the planets in the solar system. It's the only one to have a thick atmosphere. It's an atmosphere that's actually thicker than our own here on Earth, quite significantly thicker, but it's mostly made of nitrogen and methane. So it's not a very attractive place. You wouldn't want to be there. It's also a lot colder than Earth, well over negative 200 degrees Fahrenheit. And Titan is also the only other body in the entire system, solar system, to have a liquid actively flowing on its surface. Earth, of course, has water. Maybe Mars did in the past as well, but Titan has liquid methane and other hydrocarbons on its surface. And they form lakes and seas and rivers. And in fact, that methane can evaporate and then fall back down as rain. So a bizarre little alien world, very unlike anything we're used to here on Earth, but just a fascinating place. Of course, both Jupiter and Saturn have many more moons, but most of those other ones are very, very faint. But yeah, back to you, Kevin.
All right, thanks, Stephen. Wow, I'm just so happy that the conditions improved tonight, and we're getting as good a view, even including the moons and a little bit of detail there on Jupiter. Just amazing. What I wanted to talk to everybody about for just a little bit here is basically why and how these conjunctions can happen. And so I'm going to be showing you a few slides here. This is a computer-generated view. This is using a package called Starry Night Pro. And what it's showing you here is the sun in the center of our solar system and what we refer to as the inner planets. Mercury, Venus, Earth, and Mars. Earth's orbit there in green kind of stands out. And I'm going to start this video running, and as it starts, we're going to zoom out. We're going to zoom away from the sun, away from the inner solar system. Now coming into view in red is Jupiter's orbit, also Saturn's orbit there. The orbit of Uranus just came into view, and the last orbit that you see there is the orbit of the planet Neptune. Now look at that and see if you notice something kind of interesting in a way. Notice that it's all very, very flat. It's across a flat plane. It's not precisely, not all of the orbits of the planets are precisely in the same plane, but they're very, very close to being in the same plane, and that is a consequence of the way that solar systems form. Now, what this leads to from the Earth, think about this plane of the solar system. Earth is in that plane. As we look out across that plane to see any other planet, what that means for us here on the Earth is that the planets appear to only follow a certain path across the sky. They only appear in certain constellations. That line in green that you see is something that we call the ecliptic. It's basically that average plane of the solar system. And looking out and seeing other planets along that plane means that every planet that we see is always in one of 13 constellations that we call the constellations of the zodiac. Most of them have familiar names, as you can see there on the slide: Sagittarius, Capricornus, Aquarius, Pisces, Aries, Taurus. You've all heard of those before. Also shown on the graphic there is the position of Mars tonight in the constellation of Pisces. Not that that means anything personal for you, it's just where we see it right now. Also, Jupiter and Saturn together, indistinguishable from each other over there in the southwest, are both in the constellation of Capricornus, the sea goat. So we call that green line the ecliptic. Anytime you see a planet, it's always going to be somewhere along that ecliptic path and always in one of those 13 constellations. Now, let's talk about orbital periods, how long it takes a planet to orbit around the sun. This is part of what makes conjunctions possible. What we see here is a top-down view, very similar to the last view. In this case, though, just the Earth, Jupiter, and Saturn's orbits are turned on. We're looking straight down from the essentially the sun's north pole, looking at right angles to the ecliptic. I'm going to start the video running, and you'll notice Jupiter takes off, Saturn takes off. I've marked their position where they started there with little dotted circles. It turns out that the only thing that controls how long it takes you to orbit the sun as a planet is your distance from the sun. The closer you are to the sun, the more gravity you feel from the sun, and the shorter your orbital period or your year is. For Jupiter, that's about 12 years, 11.9 years for Jupiter, go all the way around. Now look at the screen, look at the graphic there. We've just about got our conjunction. There we go. It takes Jupiter about 12 years to orbit the sun. It takes Saturn about 30 years to orbit around the sun. And so it takes more than a Jupiter orbit. Doesn't take as much as a full Saturn orbit. It turns out, on average, it takes about 20 years or so in between these conjunctions, and that's what we're having tonight. We have had some in the past that we'll talk about in a bit, and we'll have some in the future that if you're very young, you can see perhaps an even better version of what we're seeing outside tonight. Now, Stephen mentioned this a while ago, and you go out and you see Jupiter and Saturn up there in the sky, and they appear right next to each other, so close that it's hard to separate them in the sky. But it's pretty clear that there's a lot of distance between Jupiter and Saturn. They're not really near each other. They just appear near each other. There's the distance to Saturn as of 6 o'clock. That's the start time of our program tonight. And the distance to Saturn is about twice that distance. So right now, although they look very close together in the sky, there's about 500 million miles between the planet Jupiter and Saturn. They only appear lined up from our point of view. So they're not really close, physically close. They are, we would say that they're close in an angular way. Now let's talk for a second about what we mean by angular measure. You can measure the distance between two objects out there, and they might be 10 feet apart and 40 feet away from you. Given that distance from you and the distance from each other, that implies a certain angle of appearance between them. We call that an angular measure. Now, you've all heard of degrees. If you're outside right now, you can, or inside, it doesn't really matter, you can measure an angle of 10 degrees by taking your hand, making a fist, extending your arm all the way out. Across your fist here is about 10 degrees. Now, Jupiter and Saturn tonight are much, much closer than 1 degree. Like our protractor here is graduated in 1 degree increments. But if we take each one of those degrees, we can separate them. We can define 60 equal measures between each degree mark, and that's what we call a minute of arc. Additionally, you can take each minute of arc, which is 1/60th of a degree, and separate that into 60 equal measures that we call seconds of arc. So an arc second is a very, very small angle. A dime seen from about 2.5 miles away equals what we would call 1 arc second. So that's a very, very small angular measure. Tonight, or actually as Stephen said earlier today, it was 6 minutes of arc. So that's about 1/10 of 1 degree, and that will increase. From this point on, they will get further and further apart. Now, in just a moment, Frank is going to tell you about some very interesting conjunctions that we've had in years past called grand conjunctions. I just wanted to point out a few that we've had in the past, Jupiter and Saturn close together, and a few that we've had or will have in the future. The last time that we had a conjunction like this, regardless of how close it was back in May of 2000. The closest Jupiter and Saturn were back in May of 2000 were, well, 1 degree and 9 arc minutes. That's 69 arc minutes total. So way, way, way bigger than they are tonight. If you go back to the 1980, very, very late 1980 and early 81, we had the same situation occurring with Jupiter and Saturn near each other, and that involved a triple conjunction. When they get close to each other and they're on a point in their orbit where from the Earth they appear to be doing something called retrograde motion, where they're sort of going forward and they back up, they're kind of near each other, you can get more than one of these conjunctions. And that was my date of entry into astronomy. That's when I started doing astronomy, back when I was in high school, during the time that these 1981 triple conjunctions were occurring. So that one's kind of special for me. Back in February of 1961, that was a fairly close conjunction of Jupiter and Saturn, 14 arc minutes, roughly twice what we had today. If If you want to get to the nearest one, going back in time, we have to go back to 1623 when Jupiter and Saturn were only 5 arc minutes, 1 arc minute closer than they are this evening. The problem there was that Earth was over, or the line of sight from the Earth to Jupiter and Saturn, well, the sun was in the way. And so that one was very, very hard to see. Tonight is hard enough to see with the sun kind of in the way, but it was even more the case back in 1623. If we go back to March of 1226 AD, we see a pairing of Jupiter and Saturn that were only 2 arc minutes, about 3 times closer than they were tonight. So that's amazing. I didn't see that one, obviously. Normal, I see this next one. Statistically, I probably won't see the October 30th, 2040 conjunction. And that's okay, because they'll be 68 arc minutes apart. 11 times what they are tonight. I saw the best one tonight. If you are young, and we've been sort of ribbing Stephen this week. He's a young guy. He has a pretty good chance of surviving until 2080. He will get to see another one of these that will be essentially about the same separation of Jupiter and Saturn than we had tonight. Now, none of you alive now will unfortunately be alive in 7541 AD. What will happen then is there will be 0 arc minutes in between them. Jupiter will actually eclipse Saturn, completely cover it up for a little bit. We don't know exactly what that degree of eclipse will be, because it turns out, because of the influence of on Jupiter, let's say, the influence of Saturn, all the other planets, all the asteroids, all the Kuiper Belt objects, all other kinds of things can affect their motion. And so we cannot accurately, at this level of detail at least, predict exactly down to arc seconds where these are going to be that far off in the future. But it looks like a promising thing to talk about, certainly. Now, Frank has identified some grand conjunctions that he would like to tell you about at this point. So, Frank, why don't you come up and tell us, what do we mean by grand conjunction?
Grand conjunction is basically just pretty much all of the naked eye planets. Sometimes you can throw in the things like Uranus or Neptune, but since those are not really visible to the naked eye, it doesn't make a whole lot of sense to include them. But the naked eye planets: Mercury, Venus, Mars, Jupiter, and Saturn, the ones that were visible since antiquity, when they end up gathering within a certain number of degrees, and it's sometimes referred to as a grand conjunction. And back on May 3rd of 2000, as Kevin is showing you here, there was a grand conjunction. Not that anybody saw it, because unfortunately, as you can notice there, the sun is right in the middle of that grand conjunction. But all 5 of the naked eye planets, and I think at one point the moon swept through it, this one as well, as I recall. But the fact that it happened on 2000, in the year 2000, for whatever reason, made some people think that it was something special. I remember lots of woo and whatnot being thrown around about ending of the world and yada yada yada. So anyway, but that was nice. Unfortunately, like I said, you couldn't really see it. But there will be another one, and at least some of us may, in 20 years, still be around. I'm not going to hold my breath, but then again, maybe I'll be there. But this one actually will be very slightly visible, and this one does include the moon, as you can see on the graphic that Kevin has popped up there. We do have all 5 of the naked eye planets and the moon visible just after sunset, about 30 minutes after sunset, as the graphic is noting there. You see that it's very low in the sky, so you'd have to have a real good western horizon. Since this is happening around September, this means that this will be very nearly due west in the sky. So if you have a good due west horizon, low horizon around 2040, make your plans now, I guess. You should be able to see all 5 of the naked eye planets and the moon. So this is a pretty rare thing. But as we can see, it does happen occasionally. Maybe one of the Venus or something will be in the morning sky, or Mercury would be in the morning sky, or all the others would be in the morning sky, and something else would be in the evening sky. So not all of them, all 5 of them necessarily, and the moon would be visible, but this is a real good one. Kevin, did you have that? There was Was there? Oh no, I'm sorry. I'm thinking about the Jupiter Saturn thing in 7,000 whatever that you mentioned.
Oh
Okay,
no, I
so
don't have that one. Sorry.
yeah, no, that's okay. So yeah, that's just that's some pretty interesting stuff. So kind of cool.
And I'm sure at that time people will be predicting the end of the world as well. And it's amazing how many times the world was supposed to have ended, and oddly enough, we're still here. So
Yeah, I keep waiting. It's who knows. Anyway,
yeah,
let me bring up my live view. Uh, I thought I had this fixed, but it's not again.
it still looks good.
Oh well. Anyway, so we do have the sky is now darker, and we definitely can see Jupiter. I think you can see that here. We've got bright Jupiter there. If you look very closely, you may see that there's another little slight brightening right next to it. But what I'll do is I'll actually zoom in on it a bit, and I think you'll be able to see that a little more easily now. You can see Saturn very close to Jupiter there, just to the right, just slightly above the line, directly to the right of Jupiter. That's pretty close to what I would have as a naked eye view. Let's zoom in just a little bit more. That perhaps is maybe a slightly better rendition of the naked eye view as far as what I can see. Saturn's a little brighter in the camera view than what I can see, but it's a pretty good match to the naked eye view as far as what the separation looks like on the screen here. So so we can see it. It's it's certainly not just one object there in the sky, not that close, but it's very close, and that's just an amazing thing. Excuse me. the Kevin, I had my telescope out last night. I'm sure you had telescopes out throughout this conjunction. I was taking a look at it last night. The seeing was just abysmal last night, with lots of shimmering and whatnot in the view. But nonetheless, just to be able to see both of those planets in one field of view of a telescope is just really amazing. It blew me away just looking at it last night.
Yeah,
Yeah,
I
it is hard to. I'm sorry, Stephen. Go ahead.
I had to look at it as well in an eyepiece and a telescope, and it's just very strange to see both of them so close, in at the sky. That's in the same field of view in a high-power telescope. That is very strange, and just one of the coolest things I've ever seen, honestly.
It almost looks photoshopped when you see a picture like that, because we're just so we astronomers are used to not seeing two objects, being able to see that they're planets, that they have some physical size, and yet they're in the same field of view. That's just awesome.
Yep. Yeah, I agree. I was blown away. I was trying to see if I could see any of Jupiter's moons. On my screen, I can actually see what looks like one of them just above. Is that correct, Stephen? Is that where one of them is located, just slightly above?
Yeah, that would be either Io or Callisto.
Okay. Yeah, I don't know whether you can see that on the stream view, Kevin, or not, but it's there.
I can't quite see it at the level right now. No.
Yeah. I do also want to encourage anyone watching us who's in kind of a central time zone or perhaps mountain time to just go outside right now and look for this yourself. I mean, you don't need any kind of sophisticated equipment to see this. Just look west right now. If again, central-ish mountain time, about an hour after sunset, which is about 45 minutes after sunset, is best. And you'll see Jupiter is pretty bright, and just right next to it is Saturn. And to my eye, I can split them pretty easily. But if I don't have my glasses on, I can't. And I still have decent vision with my glasses off. So it's kind of a vision test. And again, just to clear up any confusion, the planets are not any brighter than they otherwise would be. The significance here is that they are close together, and that is the whole significance of it.
Yeah, the ironic thing is I'm inside, not outside where I can see it.
Oh, I thought you were on the moon.
Well, it does sort of look like I'm on the moon. We're going to get to that in a minute, but no. When we're done with the stream, I will stick the doors right there, so I can stick my head out and take a look.
Yeah. Also, I want to add that if anyone wants to see the telescopic view, just rewind. We already showed that, so just rewind a bit if you are interested in the high power view of the planets.
Yeah. All right. Well, Stephen, are you on the moon yet? Or are you still on
Well, you're on the moon. I'm looking at the moon. That's how I understand it.
Oh, right, okay.
Yeah. But yes, so here is a live view of the moon. Now, Jupiter and Saturn have already gone so low that I can't see them anymore with the telescope because they are. I'll be looking at the wall. But the moon is an amazing object to see. Again, this is the live feed of the moon, kind of the northern section of it. And actually, first, I would show a low power view. Unfortunately, that camera is not responding right now, but that's okay. This is the better view. But if you can see Jupiter and Saturn right now, then you could also, I'm sure, see the moon. If you need help finding the moon, it's going to be a long night, I think. Yeah, we have a wonderful first quarter moon. That is another way of saying it's about half full. Or 50% illuminated. And when it's in this phase, we can have a wonderful a shadow line, or what we call the terminator. So the sun is coming from the right side. It's hitting the lunar features. And when the sun is at an angle like this, we see the shadows cast. So in other words, this is the nighttime side of the moon, and this is the daytime side. And we can see lots of features here, including lots of craters and large smooth areas called lunar seas. But I'm going to turn it to Kevin to explain things in a little more detail.
All right. Thanks, Stephen. I was just getting set up here. I've got a few resources I have to refer to for when we talk about the high power moon, simply because there is so much to see. I suppose some people might be able to remember, every named feature on the moon, but I am definitely not one of those people. So I have a little annotated map I'll be sort of referring to tonight, and we're going to not try to hit everything on the moon. This is not, strictly speaking, a moon tour. We will be doing our next live moon tour on February the 18th next year, so make sure you tune in for that. But we're just going to hit some high spots tonight and talk about some of the major features that you're able to see there. And I was going to ask Stephen if he might be able to kind of lower the contrast, maybe stretch that view, get us a little more brightness over in the Terminator region. There you go. Yeah, that might be a little much there, but that's certainly better. Now, everybody has noticed those two prominent craters just to the left of the center of the screen there. Slightly larger one on top. That crater is named Aristoteles, Aristoteles, named after Aristotle, of course. And right down below it is a crater known as Eudoxus. Aristotle itself is about 54 miles across, whereas Eudoxus, just south of it, is about 42 miles across. So they're fairly similar in size. The impactor that formed those craters, now we don't know for sure, but you can get pretty close, knowing the composition of the surface of the moon, which we have a fair understanding of that, and the composition of objects that are likely to hit the moon likely meant that those impactors were somewhere between about 2 and 3 miles in diameter when they slammed into the moon a very, very long time ago. Now, you might notice the terrain just to the south of Aristoteles and Eudoxus there looks a little dimpled. Go a little over to the east there, Stephen, and that dimpled view just right on top of the sea area. That is a feature known as the Alpes Formation. And it's basically large blocks of debris that were blasted out from a huge, huge impact about 3.85 billion years ago. That we call that the Imbrium event, the Imbrium impact that formed the Sea of Rains. Now that is totally in shadow tonight. We cannot see the Sea of Rains. It's over beyond that terminator, beyond the shadow. It's in nighttime right now. But all the dimpled surface there around Aristoteles and Eudoxus is debris. We call it ejecta, that was blasted out from that event and landed basically right there where you see it. Now, you've probably already noticed there's a very, very rough area just to the lower left of Eudoxus. That's actually a mountain range on the moon, which again is related to the Imbrium impact about 3.85 billion years ago. It forms the border, basically, of the eastern border there of the Sea of Rains, that mostly hidden.
So I do want to clarify for those watching. Again, we've already looked at Jupiter and Saturn. We're going to take a look at the moon now. So feel free to rewind and where we went into detail and showed the live view of Jupiter and Saturn. And the shimmering you're seeing also is the same thing when we saw Jupiter and Saturn. It's the Earth's atmosphere. So yes, the image is moving around.
Yes, that's proof that this is a live view. This is not pre-recorded. Now, there's a small crater over to the east of Aristoteles and Eudoxus. It sort of forms a right triangle with Aristoteles and Eudoxus. And that small crater, that's the one right there, is called Berg, B-U-R-G. Not so much Berg that's interesting to me, it's that little area of darkness that it sits in, that smooth area, which is one of my favorite name features on the moon. It's known as the Lake of Death. It's the Lake of Death
That's
sitting
one of my
right there.
favorite names too. I love
Yeah,
that
it's
name.
just awesome. There's some very whimsical names of some of the seas on the moon. Which, let's talk about a sea. We can see a sea right now. We see about half of the Sea of Serenity. There, we got a little wider view. That big circular dark patch that you see right down below Aristoteles and Eudoxus, that is what's known as the Sea of Serenity. Now, these are not water seas, these are lava seas, and not liquid lava seas, but solidified lava seas. Some of these seas also mark the locations of giant impacts on the moon that occurred billions of years ago. Basically like a crater, just a much larger version that we call an impact basin. Some of the seas sit in impact basins, some do not, but Serenity is one of those big dark basaltic lava flows that happens to sit inside of a pre-existing impact basin, and we call that the Sea of Serenity, and it is about 440 miles across, which is a fair amount, but that's, like half the distance from Orange, Texas to El Paso, Texas. That's about half the size of the state in which we are located right now. Tell you what, Stephen, let's go down to the Sea of Serenity. That's one that everybody's heard of, and like I said a few minutes ago, we don't
You mean
want to.
Tranquility?
Oh, what did I say? Serenity again?
Yeah.
Yeah, thank you for reading my mind. Tranquility. If you ask somebody to name a sea on the moon, of course, they're going to name the Sea of Serenity, which is kind of shaped like Pac-Man. The
Yep.
mouth of Pac-Man is right down on the bottom. Yeah, kind of like Pac-Man. Now, the Sea of Tranquility does not sit in an impact basin. It is simply an area of lava flow out onto the surface billions of years ago. And it's one of the darker seas as well. It has a very high titanium content in the minerals there in the rocks. And it's one of our favorite seas. It's also the location of the landing site of Apollo 11.
Right.
Right about in there, yeah.
In that region. Not that we can see it, but it's in there.
Yes, can you zoom in just a little bit, Stephen?
Yeah.
What I look for when trying to find this region on the moon are those two small twin craters over there on the southwestern shore of the Sea of Tranquility, which are called Ritter and Sabine. Ritter and Sabine, in addition to that very small crater that you just pointed to there, which is known as Moltke. And the Apollo 11 landing site is right in that region. And I wanted to show you, let me get a slide up here, because I did want to show you just a few slides that do relate to the Apollo 11 mission. All right, let's see here. Let me see if I can bring this up for everybody to see. Here we go. Yeah, Apollo 11. Everybody knows who these three guys are. In fact, if you ask most people to name all of them, they have no problem because they were the first to land on the moon and or to journey to the moon, and two of whom walked on the moon. The crew was, of course, Neil Armstrong, Edwin Buzz Aldrin, and Michael Collins. The two that got to walk on the moon, we call them moonwalkers, were, of course, Neil Armstrong and Buzz Aldrin. And, of course, when they landed on the moon, Neil Armstrong's famous words, "That's one small step for a man, one giant leap for mankind." Michael Collins, the command module pilot, by the way, his job was to stay up in the command module orbiting the moon during the time that Neil and Buzz were on the surface to take care of things up there. Here we see a fairly rare shot of Neil Armstrong there on the left, because it turns out he was taking the pictures most of the time. He's sort of like me. He's the one that wants to be behind the camera, not in front of the camera, which is ironic tonight. But that's actually a photo of Neil Armstrong there on the surface, and there on the right is Buzz Aldrin saluting the American flag after they had landed on the moon and set up some of their equipment. Now, it wasn't known for sure back then, back in the late 60s, if there were or could be any microorganisms, anything living on the moon. And so we weren't entirely sure that the crew coming back would not bring microbes from the moon. And so they had to quarantine. Many of us these days are familiar with that process of quarantining for a little bit. They had to stay in their quarantine trailer there for 3 weeks. And not only the Apollo 11 mission, but also the next 2 missions that returned from the moon had to stay in quarantine. And there on the right there, you can see President Nixon talking to the crew inside of their quarantine chamber there. What do you want to do when you get out of quarantine? Well, you want to go have a big party or something. And they had a gigantic party in New York City when they got back, got out of quarantine. They actually had several parades. This one was the one in New York City. Okay, well, I just really wanted to show you all those because they're pretty cool. Let's, Stephen, can you bring the moon back for us?
Absolutely. There you go.
All right, now let's go down south a little bit. I want to show you another sea. This time a small sea, the Sea of Nectar, which is also a small, well, it's a fairly large impact basin. The impact basin is larger than the sea that we noticed there. In fact, can you highlight the Altai Scarp over there, just to the southwest, that kind of bright line that snakes away?
There you go.
Yeah, that thing. That is actually part of the outer rim of the impact basin that formed the Nectaris Basin, in which the Sea of Nectar sits there. Small lava flow there in the middle of that impact basin. There's also 3 craters that border kind of the northeastern border there of the Sea of Nectar. And those craters, starting from the one on the north, the best defined one is Theophilus. And just to the lower left of Theophilus is Cyrillus. And then down below Cyrillus is Catarina crater. These are all similarly sized craters. They're all about 70 miles or so, 60, 70 miles across. One of the things that I really like about this trio of craters is how we start with the bottom one, with Catarina being the oldest, most eroded crater. In fact, that one mostly dates back, we think, dates back to the formation of the Nectaris Basin. But it's had, many more billions of years to get eroded, be pounded by meteorites, things hitting the moon, softens the features, and so that is the oldest one. There you go, nice close-up view. Then we move up to Cyrillus, which is more recent than Catarina, but less recent than Theophilus. And notice that both Theophilus and Cyrillus have something in the middle. Those are what we call central peaks. Those are features that basically are a rebound of the floor of the crater immediately following the impact. The bottom of those rock layers will rebound back up, splash up in the middle, and form, literally in minutes, a group of mountains in the center of those craters. The ones in the center of Cyrillus are slightly taller. We don't have as good a view of them. Their slopes are not as illuminated right now, but they're actually a little bit taller than the central peak in the middle of Theophilus. Back when we were fully open, back in the before times, as we call them, we had a program called a Lunar Twilight Program, during which time we would go into a crazy amount of detail about the moon. Stephen, can you bring up that high view of Theophilus again?
Oh, sure, yeah.
Last thing I want to say on this topic is that the central peak in the middle of Theophilus looks very much like a fist. I don't know if I'm making exactly the same sort of shape. Somebody in the group pointed that out to me, that it looks like a clenched fist, and now I can't unsee it. Every time I see that, I'm reminded of that person who put that image in my mind, and now that's just what I see there in the middle. Last thing, Stephen, if you could pan over, zoom out a little bit, pan over along the terminator, we should be seeing 2 enormous craters just a little further north up the terminator from Theophilus, Catarina, Cyrillus. Go up north just a bit.
Oh, yeah, north. Yep, there you go.
The other north. Yeah, those 2 craters right there on the lunar terminator. I really like looking right along the terminator because you can see that the rising sun is catching the rim, the western rim, the far rim of that lower crater on the moon, which is called Albategnius. Albategnius is a 80-mile wide crater, and those peaks on the rim, on the western rim of that crater, are sticking up high enough so they are catching the morning rays. And then the large crater right above Albategnius is a crater, a 93-mile wide crater called Hipparchus. And Hipparchus has several superimposed, more recent craters on top of it there. Their western rims are also catching that rising sun. If you have a small telescope, you don't need a big high-power telescope to get a great view of the moon. All that you need to do is take out your small telescope. You don't need a dark sky either. Take it out and look along the terminator. Whenever you can see it, you're always going to get the best views of the moon along that terminator. Okay, well, I think that wraps us up for the moon.
And once again, if you're just joining us and you're looking to see Jupiter and Saturn, again, they are too low for us to observe now. You've missed that part, so just rewind and you'll see the live view, the high power view. But Frank is here to show us a wide field view, what it looks like with the naked eye. Again, too low to see with the big telescope, though.
Right. Yeah. So I wanted to come back to since we can't see it with the telescope, made sense to come back to a wide field view here. So I'm having some technical problems. Hang on just a second. All right. So yeah, I've had software crashes and I've had all kinds of lovely stuff going on, but we do have Jupiter and Saturn on our view here. So of course the bright spot here is Jupiter, and the camera is saturated enough that at this point now the Jupiter is saturating its little spot there that we're unable to see Saturn as a distinct target. And so what I want to do is zoom in here to show us that in fact actually you can see the edge of just on the edge there, dot of Saturn still visible. So let's zoom in maybe just a little bit. Now we're actually going to be digitally zooming a bit to give you a little bit of separation. But yeah, you can see basically with my naked eye, I can easily see Saturn separated from Jupiter. But one of the disadvantages of cameras is that they just don't work the same way as as the human eye does. And one of the things that happens is that the pixels get saturated and they start overflowing with bright objects like this. The electrons start overflowing into neighboring pixels, and things that are bright end up looking big. And so at this point, Jupiter is far larger than it should be with the view that we have with the naked eye. But nonetheless, you can see that we do have a view of Saturn and Jupiter. And it looks like my camera view has frozen yet again. So, but good thing it froze on the thing that we wanted as opposed to freezing on something else. So, yeah, anyway, well, looks like Stephen will have to explain some of this to me later because I'm not a Windows guy. It's showing the camera working on the live view, but not on my preview here over here. So that's weird. Anyway, all right. So that's what I got.
That's pretty cool. Oh, that's interesting. What is that?
That was me accidentally kicking the tripod leg.
Yeah, we never claim to be professionals here. So there you go. All right. Well, we had sort of kind of planned on looking at Mars this evening, but well, we kind of run out of time. We want to do a few Q&As, and if you want to see Mars at its best, actually, you need to go back and watch Stephen's. Was that the Planet Fest when they were really close?
Yeah, that's correct. Yeah, Mars at the moment isn't the greatest view since it's so far away. But yeah, back in early November, we did some great views of Mars, and you can go back on this YouTube channel and find some of our past live streams. Also encourage you to subscribe to our channel and get alerted of other programs, other live streams. We do stream deep sky objects as well as planets and the moon and as well as the sun. So yeah, go ahead and subscribe to our channel to learn more. But yeah, at this time, we're going to take a couple questions, see what we have time for, and see what questions we have for us at the moment. No question. We're going to find a few. Just give us a quick moment. And once again, I do encourage anyone watching in Central Time or Mountain Time to just go outside right now, look west, and find Jupiter and Saturn right next to each other in the sky. So yeah, it's a great view, naked eye, just like you saw from Frank's view. It really looks just like that.
Or if you can't see it tonight, go out tomorrow night. They'll still be really, really close in the sky. Maybe better weather for you. All right, I can't see any question feeds, so if somebody can.
Yeah, I've got some questions. Yeah, okay. So, do we ever observe new impacts on the moon? That's a really great question, actually. I'll let you answer that, Kevin, since Kevin's the moon man.
Okay, the moon man, which is sort of ironic given that before starting the moon tours earlier this year, I had relatively little interest in the moon and more of a deep sky observer. But anyway, Iron Eagle asked, do we ever observe new impacts on the moon? The kind of quick and easy answer to that is no, because most of the heavy cratering on the moon ceased about 3.8 billion years ago or so. Not a lot has happened on the moon since then. There have been certainly noticeable craters on the moon that have happened in that intervening time. But within the last 100 million years, no, there have not been any noticeable large impacts on the moon. But the moon doesn't have an atmosphere, and so anything inbound to the moon, even the smallest little bit of debris, is going to hit the moon and make a crater on some scale. So it's mostly a matter of scale. The Lunar Reconnaissance Orbiter that orbits the moon has been for about a decade or so, has spotted small impacts on the moon that have occurred just since it entered orbit back in 2009. But on the large scale, no, we're not seeing any sort of big changes on the moon, simply because most of that happened at a time in the solar system when there was just a lot of stuff flying around, hitting everything, including the moon. But most of that stuff has already hit something by this point.
Yeah. Kevin, if I could add to your answer, one of the things that the high-speed digital cameras have allowed people to do is actually observe the impacts, very small impacts of meteor showers on the moon. When the moon phase is appropriate, essentially when it's relatively unilluminated, and we're having a meteor shower. Of course, that meteor shower is happening over a very wide field, much larger than just the Earth. And so some of those meteors will impact the moon. And people have actually been able to image the little flashes of light from the impacts of small meteors on the moon. Now, once again, we're not seeing impact craters from that sort of thing, but we are seeing the evidence of that stuff being the stuff hitting the moon's surface.
Right.
I got another question here. Don't know why that one just disappeared. But how many craters are on the moon? From Trevor H10. Well, you could spend your whole lifetime, I guess, counting them. It's really hard to define that because the more you zoom in, the smaller and smaller craters you'll see. So there are many thousands of craters. Most of the ones we see in the telescope are many miles across, usually 10, 20, 50 or more miles across. But if you were to actually go there on the surface, you would see that even tiny little meteorites, just size of a grain of sand, if they hit the moon, they would leave a tiny little crater, which would be there for many years because there's no wind or erosion to erase the craters over time. So more than you can count. I don't know if there's really an official answer, but many thousands for sure. Until when will the conjunction be visible? So tonight was the peak of the conjunction, when the two planets are closest. Technically, that occurred a few hours ago, and what we saw at the start of the program was not actually the true peak of it, but it was daytime here when it was the true peak of it. But you will still see the planets close to each other for the next several nights. So it kind of depends on how close you consider it until it's not a conjunction anymore. How far apart do they have to be before they're not conjunctioning is sort of a unestablished thing. But yeah, tomorrow night you will still see it, and then but every night after tonight they will slowly be drifting apart from each other, and they'll be getting lower and lower in the sky at sunset. And so eventually you won't be able to see them anymore in a few weeks' time. And yeah, one last shot there from Frank of the real-time naked eye kind of view.
Yeah, and we're noticing some satellites coming into view now as well. Just figured I'd bring that back just to show that. The reason the satellites look like a streak is because this is now a 4-second long exposure, so we're getting a trail of a satellite as it moves across the sky.
Thousands of satellites up there.
Yep.
It's a beautiful view.
Yeah.
Sohan asks, would the conjunction cause any disturbances in the galaxy? Not really. So as you saw earlier, although they look close to each other in the sky, they are over 450 million miles apart from each other. And so they don't really cause any effects, really. It's only from our perspective here on Earth that they look close to each other, but in fact they're very far apart. So nothing to worry about, no concerns there. I think we have time for maybe 1 or 2 more questions before we wrap up for tonight. What defines a conjunction? Do they have to be visible in one telescope view? It's always cool when they are visible in one telescope view, but no. When we say a conjunction, basically we just mean we usually talk about one object in the solar system is appearing close to some other object, which could also be another planet, or it could be the moon, it could be an asteroid, it could be whatever. But for the most part, when we talk about conjunctions, we mean that there are 2 or more planets relatively close to each other in the sky, usually a few degrees in the sky. This is a very close conjunction, but again, conjunctions in general, as a concept, they're not rare at all. There's several conjunctions between the moon, the planets, and other things throughout every year. It's just that this is a particularly good one. But there's no hard set rule, I think, on how close they have to be exactly in order to be considered a conjunction. It's very subjective. Have time for maybe 1 more question if we have one. Trying to find one last good one. We're going to try to make it a good one.
There's a lot.
There are a lot of questions. Where can I see Mars from Betty, age 12? Well, if you go outside right now, if it's dark where you are, then look almost straight up, pretty high, slightly east. But Mars is up very high in the sky at the moment. It's not as bright as Jupiter. Jupiter is a bigger planet, and so despite the fact that it's further away from us, it's still brighter. And Mars is currently moving away from us slowly, and as its orbit takes us further apart. So it's not the ideal time to view Mars, but you can still see it, and it's almost straight up at the moment. So it's pretty easy to spot, and it's slightly orangey, not nearly as red as people imagine it to be. But okay, I think that's all the time we have for our program tonight. Thank you, everyone, for joining us. I really appreciate everyone sticking around. I'm really thrilled by the huge turnout, and I know we had a lot of questions and we couldn't get to all of them tonight. But yeah, thank you so much, everybody. Thank you, Kevin and Frank, and all our moderators as well.
Thank you, folks. Appreciate you being here.